And good to see everybody on. Hello, everybody. My name is Kevin Kotchak. I'm the founder and CEO of Chemical Q Device. Here's for Thursday, May 16th, 2024. So this is the LangChain suite. And if you've done anything with large language models, you probably really want to see this. It's the #1 developer community for Gen AI, meaning, most of the LLMs are generative AI. And of course, this has huge implications. People are already using Gen AI for drug discovery. And these are more like the advanced workflows that are, really important to utilize. Now, if you were to look at this, as far as this stack here is basically at the bottom, is you have the protocol. And, so this is LangChain Core. Now, in a lot of the demos I'll be talking about, they always refer back to this LangChain Expression Language, so LCEL. So this is for parallelization, fallbacks, tracing, and much more. And then they list the next thing as far as the LangChain community, model IO, retrieval, and agents. So those are two big things that I'll be talking about. So retrieval, typically the term that people use is RAG, retrieval agent generation, meaning that whatever comes off the large language model, that generation gets augmented, and then it gets, you're seeing that augmented response instead of just seeing the plain large language model. Now, for LangChain itself, there's chains, agents, retrieval strategies. I mentioned two of those. Chains is just more like it's not an agentic workflow. However, they've been working quite well. They're typically very efficient, and they're not as flexible because they're more defined. But if you have a specific use case that you want to use your LLM output with, people are using chains. And then, of course, you have templates. Now, LangServe is basically taking the large language model, turning it into an API. That was the only part that I wasn't able to get to this week out of the three. And then LangSmith, I spent a lot of time on LangSmith. They give you 5,000. It's not tokens because that wouldn't last too long. It's basically these instances. And I only got up to 150 during the whole week. And I was running many other notebooks beyond just what I was showing in this presentation here. So basically, LangChain itself, it's quite big. So they say 14 million downloads a month. So this is every time you use it in the notebook and it says, import LangChain, use API key from LangChain. That's what is counting for that downloads. And, they basically say flexible abstractions and AI first toolkit for building Gen AI. And they say they have the largest community for building these LLM apps. And it helps connect these LLMs to private data sources. Now, if you didn't know, 95% of the data in the world is private. 5% is a huge chunk, and that's actually represented, in specific with, when we're training off those large language models, the original trainings is what we see there. And you need to use LLMs because they have context, because it's seen so much data, like trillions of tokens, but terabytes of data. And it's just really important to have that basis down, for reasoning. And the next thing as far as LCEL is, and I talked about some of these things, but they say 100 templates, 2,600 contributors, 600 integrations. And you have to keep in mind that all of these, the flow charts I'm going to show you coming up here, it's all to get better outputs. And then also with LangSmith, which I'll mention here, is it also aids in explainability or interpretability. Now, it doesn't take care of the problem with LLMs to hallucinate and these types of things, but at least you can see what's going on step by step. And if it seems like an output was, more kind of dreamed up than factual, it can actually, using these other tools to go back into the loop and then create and generate a new response. So it's on the software side. So if architecture, you want to change your architecture to be more explainable, that's totally something you can do. And other people have used tensor networks to gain explainability and transformers and GPT models. So the key thing is they call it a trace. So I'll show you as far as what's coming up here on the specific screenshot. And, a trace basically says in this specific step, it took, this many tokens, it took this amount of time, and then it'll kind of give you an estimate as far as how fast that is. So red is bad, green is good. So I'll show you that. So I would recommend everybody to try it. It's free. And like I said, of all the coding I did this week, I did not use more than 150 of these traces. Again, they're not measured in tokens. And then if you go over the 5,000 at some point, then they have a plan for that. So it's basically, it's a graphical interface of what you're receiving in the notebook, but it's put together so you can easily scroll through things. You can see the exact dates. And it's kind of like a notebook companion in a sense. And I think the information coming from the notebooks, you can access a lot of that, but this puts it together in a package. And say, for instance, it's well integrated with OpenAI and all the LLMs there. So LangServe is basically the next step. So you have your LLM, and then the next thing is to turn it into an API server. And so this is all available. It's probably of the three, it's just another tool to use. And they say it's built with fast API. So this is for API for docs and playgrounds for your LangChain apps. Okay. So again, these three are, super important. They say #1 community for Gen AI. And if you're doing anything, with large language models, before I started this, these experiments this week, I would come across a lot of these models that would say, pip, import LangChain and use LangSmith more like. And they offer a ton of notebooks. So if you go onto GitHub, there is a couple of different places you can look. But this one caught my eye because it had a YouTube video. So I watched this discussion and, I have the notebook. And if you recall from previous weeks, is basically I'm setting up as far as kind of this agentic workflow. And one leg of it is to correct its own code. So using that notebook, and I had one kind of minor hiccup with it as far as an error, but I was able to get decently far with it. So this is the type of workflow that you see that it's relatively less flexible, right? So if you have a full out agent, which today we can't get to work quite as well as say like these more kind of static workflows, there's benefits in doing it like this. And so this is basically LangSmith. So a lot of this stuff like the table and the figure, where it says that's been added. But this is kind of what you see. Also, I put in the URL as far as where I'm getting this information. And I also put in the question here too as well. So you see, I'm using this for run 3, and I'll get to the table a little bit soon here. So basically what it shows is for this whole workflow, it took 24.8 seconds. So that's reflected in time at the bottom. And then this 10,600 tokens. Now, for certain types of LLMs, you can't go above a certain threshold for tokens unless you pay for another tier. So I know with the GPT-4o that just came out that I'm using it for run 2 and 3. This one in specific, based on my tier that I'm currently at, I couldn't exceed a certain amount for other types of, notebooks. So that's one of the things that you look at. And it goes through step by step. So this is a collapsed view. So you can also, open up each of these and take a much closer look as you go through. So all the way up to, generate and then check code. Now, this is on the check code screen. And the code assistant is basically this. It can do a couple different things. And I pointed it to one of my GitHub pages. So when these LLMs are trained, they're not trained perfectly on all the data. It just gets sometimes a summary. From some of the papers, it was seeming like not the whole paper, but more like it says, it gets kind of a little bit more than an abstract, but I asked it about a specific table. So this specific directory I pointed to, and it has some of my notebooks in it. And I asked it, how do I fine tune Llama 3 with the mole instructions data set, which is what I used? And then it generates this answer, okay? Now, the other part was on the code side of it too. You can ask it a question code, and then I'll put it into, a specific format. So what was interesting about this is that now going to the table here, this run 1, 2, 3. Now run 1 with Claude 3 Opus, it's it's from a different manufacturer, and I used the L4 GPU, which is new to Colab. And a lot of times it beat the A100, I think 2 out of 3 times as far as time, and then especially cost. Because going from, so if you look at this for the Claude 3, and you look across, 74 seconds, and the other two, based on using an A100 or an L4, you see these are like 23 seconds, 24 seconds, and then the GPU cost, is just lower in some of these other ones. So the most important thing, and the reason why people spend more money is of all importance, unless you can't afford it, is to get the best output possible. So the takeaway message here between all of the different types of workflows I'm showing you, as far as Code Assistant and 2 other ones, which I'll get to, that's the most important thing. So the GPT-4o just came out this week. It's supposed to be as good as I think it was as GPT-4, the fast version and turbo. So, you'll see with these other ones, it's just more accurate than the Claude 3 Opus, which is a different manufacturer for there. So that's the first one. So for Code Assistant, and if you're just joining, it's the workflow. So you run it in your notebook, okay, just like normally, like with Colab, but then you're pointing it to, in specific, all these LangSmith tools, right? So you go into a web browser and then you pull this up. And again, I put the URL, I put the question in there, and then you go through. It doesn't have the table, but it's a good tool to have, because it's kind of like you need a second notebook anyway, because if you were trying to print everything into your Colab or whatever, and it goes like new line breaks and these types of things, it's hard to visualize. So it's a good tool. Like I said, I'm only at 150 out of 5,000 of the traces allowed. Now, this other thing, as far as LangGraph, it's used to do these multi-agent workflows. So compared to chaining, which are more static, it's currently taking more time, fixes, and resources. It has people buzzing because it's a precursor. So agents are a precursor to, general artificial intelligence, thought to maybe get to us in a good form in about 5 years. And, it's basically, it has more flexibility, but at this stage, it's still kind of like going through a loop. Now, I think it was Harrison Chase put it, he's the CEO of LangChain. It's like running a language model in a loop in a variety of ways, okay? So it does have some pre-programming to it, but it's not as fixed as if you're trying to do some other LLM tasks like you normally would. It says, so the state machine and a label-directed graph are pretty similar. And the state is a node. So you see a lot of these things as far as diagrams from LangChain. And the edges are how they communicate, similar to Network X. Okay. So the one that I chose to develop on, so this notebook ran very well. And it's basically it's an agent supervisor. So main thing for the user is to submit a prompt. So you say, I want to know more about, a cancer drug discovery, in 3 different ways. Give me 3 specific ways in 2024. And that's something, it should be able to do. And, so the supervisor, which is software, has these other agents. So in this case, I think it was just 2 others, researcher and coder. And, the sky's the limit as far as different types of architectures of agents. This is just one. And this is the LangSmith as far as I run the code in my Colab. I go over here and I see how many tokens. So 4,500, not too bad. And it depends on what I'm giving it. So when I say write a research report on the article, in this specific case, this workflow, it didn't seem to point, well, actually it did give a good summary here. And it goes on for, multiple other, headings too, as far as some things up there. So yeah, but sometimes you do have to use certain other workflows in order to get a more precise and accurate and focused a review of like this retrieve content, either it be online or be it, if it's private to you. Okay, so the next steps after here, so you'll see, as I showed you before, we have the researcher, this coder, the supervisor, and the user. The user's me, I put in the prompt. And you'll see here, for this specific task of the supervisor, I could click on, and it'll show me all the, specific, how long it took for each task. and it'll say what it does too. And I'll show you in the next example through these workflows. I gave it some of my information too, and I could see it start to look through all kinds of stuff that, would have no value, but it's just not pointed correctly. And then so we see supervisor to researcher to supervisor to coder to supervisor. So this specific part of the notebook worked. I'm sorry. This did work. The whole notebook worked in this specific case. So the notebook to get this from is called Multi-Agent Agent Supervisor, and this is on LangChain. Now, in all these notebooks, it didn't take too much to get started. You have to get the keys. These API keys live on the Anthropic, which is, the Claude that I showed you before, or they live in, OpenAI.com. And in my experience, I had to pay like at least $5 to OpenAI to get to the GPT-4o, which, is kind of like their exclusive model, which is doing well in all of these experiments. And LangSmith 1.2, or actually it's technically LangChain, but then you set it to a project name, and then the LangSmith sends it to, the notebook sends it to LangSmith, and then you can have it so it's a lot organized. And I was getting better at doing that as I went. But say if you want to do agent supervisor on an L4 versus an A100 versus some TPU, if you can get that to work, you can specify that. So when you go to LangSmith, that folder will highlight. So this 9 and 10 is their original notebook, and then the ones I modified. So I went through, I had to put in my keys, I changed this research report as far as what I want for it to look at. And, sometimes you have to go in because it'll say like to focus on something, like to set up the template before it even starts to search. So you have to search, throughout the notebooks to make sure it doesn't start, thinking that it should be an expert in some area. It's basically, setting it up beforehand. Now, coming to this one is basically, I said, write a research report. And this is, if you were just tuning in here, it's based off of this framework. The user is me. I submitted the prompt. The supervisor is taking in these other agents, which are other, software. And it could be, plain LLMs, or it can be LLM plus whatever. If you're using RAG, LLM plus whatever. So in this specific case, it's the researcher, the coder, the supervisor, and then the user. Okay. So, and that's reflected in this left-hand corner, or left corner is, you see supervisor, researcher. And sometimes these print more than, a separate block. So this is a specific block that it's showing. And so going to the table is basically this, so I'm calling my run number 1 GPT 3.5 Turbo, which is really cheap. If you go onto OpenAI, it used way less, dollars or whatever. And I didn't spend that much with OpenAI to begin with, but it's just really economical. And unfortunately, a lot of these answers are kind of limited by the original LLM. And there's all these tools, with agents and, other things to, try to influence like a poor answer and have it run it again. And there's, it's just the way that it's set up. So using GPT 3.5 Turbo, even though it's cheaper on the tokens, using GPU time with an L4, it's 94 seconds. So you're in between, it's supposed to be 10 times more expensive to run GPT-4o. But in this specific case, it's actually less expensive because of GPU time. And the cost was the most expensive for the worst LLM, right? Because it took more time. So where this says 27.34 up here, it would have been 94.42 seconds in that specific run. And like I said, above all these things, and my takeaway from it is all this is pretty economical. I would say you kind of have to watch out for like the GPT-4o a little bit if you're running a ton of tokens. So anytime that you have like these massive documents, the words are represented numerically as tokens. So one token is going to cost more either input and output if you're using the new GPT-4o by OpenAI. Okay, so beyond all that, the most important thing is actually the output. And like I said, with this run 2 and 3 that was based on 4.0, the new LLM, similar types of responses, thorough. But this first one actually was less concise. And, so it didn't pay to use the worst LLM in this case, because using GPT 4.0 didn't require nearly as much GPU time. Okay. And again, this one's available, Agent Supervisor.ipynb, and then this is definitely up on the GitHub, their GitHub, and then the number 10 is my modified version. Now, the thing that's probably most exciting about all of this, as far as what's really working well today, I found it's called RAPTOR. So this is another seminar that LangChain had. And if it wasn't Harrison, there's one other gentleman that does a lot of these too. Recursive abstractive processing for tree organized retrieval. Okay. So what it is basically you have some documents. In my case, and in the demo's cases, we had 3. So usually you're just looking at one. Okay. And the problem with, just relying on the LLM to do the whole internet is because it's a compressed form. It's not in specific, supposed to be an expert on a specific paper. So the RAPTOR, what it does is you have these raw documents and it clusters them, okay? And then it forms a cluster summary. And then from the cluster summary, it goes to more clusters into a root summary. So all of these go to the vector store as far as how to access this data, vector store. So if it'd be like Weaviate or something like that, as the available information that it's been, clustered so many times. And this was a separate YouTube discussion, and I really suggest looking at it because it really worked well. So what I'll show you up here is I say, how is cancer being addressed in generative AI drug discovery? And I said, give me a specific example. So the first one is a good research paper. It's this drug discovery one. It's basically 2024 generative AI and drug discovery. And these next 2, because if you look up here, the tokens was at 9,900. If I go over 10,000, then I couldn't use my GPT 4.0, right? So these are the things you have to weigh as far as you want GPT 4.0 performance. And I think that you can get to much higher token levels if you keep paying them. But anyways, this is the combination of sources that worked. So the first one is more of a full-length, research paper. The next 2 are my weekly updates, which have a ton of information, but they're not nearly as verbose as a research paper, in 2 different parts of chemicalqdevice.com. So what was interesting about this is it was very flattering, and actually with the GPT 3.5 turbo that I ran on an L4, it only took 2.45 seconds, which is really low GPU costs. So the way to do this is you have Colab, and it's credits per hour. So to do it into dollars per hour, it's just times 0.1. And then I turn dollars per hour into dollars per second, and then times that by seconds to get GPU costs. Okay. So this first run with using GPT 3.5 turbo, it just starts talking about me. It says process initiated by Chemical Q device, founded by Kevin Kotchak. But if you look at the original question, it doesn't really talk about the expert. It actually says, how is it being addressed in Gen AI drug discovery? Give me a specific example. So it didn't actually cite that again as far as saying this specific example is. It just kind of got caught up in the document and it lost context from the original question. And if you're a pro, which everybody should be at this point in my estimation, and you do ChatGPT and Meta.ai, because you're going to have to interact with AI in the future, if not now, soon, is that you notice changes between switching from 3.5 turbo to GPT 4.0. And actually previous works, I was on GPT 2. And unless it's like very fine-tuned to the specific application, you can get all types of answers, and that's not necessarily wanted. Okay, so run 1, GPT 3.5 turbo, which is by OpenAI. GPU cost was low. It was similar to the GPT 4.0, but less relevant. Okay, so when you go to check out how much you're spending between all these things, because you want to have an idea of what you're doing. The main thing on OpenAI.com is the number of times you basically access it and the cost per token. So like if it's like, I think for GPT-4o, it's $5 per input token, $5 per million input tokens. And then I think it's 15 for out tokens. So those are the two things, but I did see some discrepancies between LangSmith. If I check on it and I would hover over like where it shows here, it would show the an incorrect rate. It's based on this specific notebook I ran at GPT-4o, and it's based on GPT 3.5 calculations. So just watch out for that. And again, it's hard to start ringing up the bill, and especially you have to say like keep updating whatever. But it's you have to know what you're doing at that same time. So figure longer documents, longer text, more tokens, if you're asking the AI to look through it. Okay. So in run 2, GPT-4o, which again came out this week, and I ran the A100, which has been the #1 GPU on Colab for many months, and it actually ran slower. And if you look at the specs, you can kind of see the differences between it. It's this L4 is based on a smaller die size, and it's just, I ran across an article that says it's typically beating A100, although the A100 still has 40 gigs, and we'll probably see a refresh with the A100. Okay, so you see the GPU costs go up with this because A100 is about, it's a little over 2 times more expensive than the L4. Now, the one that's shown here is run 3, and in specific, I used the L4 again, and I didn't come close to anything. I never had it. These examples aren't taking massive amounts of text and say, like, if this is like looking at, 10, huge summaries and different areas of technology, it's not that. So using GPT-4o, and it was actually, slightly faster than 3.5, but it all comes down to the results. So if you're setting up notebooks and you don't know what you're doing yet, is you really want to just put in like a 3.5 turbo to just get it working. And another thing is you don't want to keep rerunning the whole notebook. So once you have the installs and all that kind of stuff, go to the specific cell and then hit run after. Because every time you run the notebook again, it's going to redo the calculation, and then you'll see on OpenAI. And again, the costs I thought were very reasonable, and I still had some credits from OpenAI, and then I spent another $5, and that helped me to use GPT-4o. So it's kind of like you get what you pay for, and especially with outputs, right? So these bigger models just are trained to have better context and even bigger context windows too. So, and you'll see, using this L4 with the GPT-4o, everything's in the green. And it's mostly because of RAPTOR, right? So however this notebook was set up, and I go through and I make modifications to it, it runs fast, the results are good. And it's, if you don't want to only look at a single source, so again, I would be 3 of these. So mine would be green, orange, and purple instead of the rest of these. And then, it still does all these clusterings. So they spoke very highly of it, and actually, it was an important notebook, so I wound up watching this additional discussion on it, and it was well worth it. So, the question is basically which is in specific, LLM application should you use, right? Should it be an agent today, which is, the performance isn't as good, but everything's going in that direction as far as giving, more autonomy to the software. And then over here, so this is what was run today with those 3. So GenAI RAG, so that's a RAPTOR, retrieval, and then it augments the LLM. And again, OpenAI was used, and also Anthropic, which has the Claude. Okay, so the Claude, if you joined a little bit later, didn't fare as well. And then the older version for the GPT 3.5 didn't fare as well as the 4o. So the 4o actually performed very well, and it also does multimodal data too. And then for the read and write, the code execution, this is the only one later in the notebook, it did get an error. And it actually keeps processing through to try to get it. So it could keep trying to iterate. But it had some error with a transformer. It's called datasets in that specific case. So these are the 3 notebooks that were presented on today. And in summary with this is basically, this is the #1 generative AI LLM application developer community. Now, you may not realize this, but the previous discussions I did on, Llama 3, both the 8 billion, and then I also did some 70 billion, work on that too, is that this is kind of like the ground truth. Like if you want to be an AI, there is a level of complexity, and, you just have to just approach it like you're going to fail like many, many times, especially in the beginning. But then if you stick with it and don't give up, you'll start to emerge, as far as more people looking up to you. Now, again, with explainability, this is the first time I saw it posed in this specific context, but I think it is a valid way of addressing explainability in large language models. In particular, we always talk this, more as a nonlinear connections, like these fully connected neural networks that are inherently not explainable, which these LLMs use, or could we switch to a different architecture? Now, this is more saying that, and I heard Sam Altman talk about this before, as, is there a specific way of re-looking at explainability as far as the answer? And LangSmith approach addresses that because it puts all this information, you can read exactly what it's trying to do, and it's built into architectures or these more like workflows. And then it can, instead of using a less explainable answer, either try to regenerate or use RAG. And, to a certain extent, the type of workflows that you use is really up to, your imagination, right? It shouldn't have any firm caps with it. So LangServe is the last piece there. So it helps LLM apps turn into an API server using fast AI. Now, the results today were basically this. With the code assistant using GPT-4o and NVIDIA L4, this GPU, for higher output accuracy, but there were some errors, even though it could keep iterating through. It wasn't, there was some issue with it. Now, the agent supervisor ran well. The GPT-4o was most concise and less expensive versus GPT 3.5 Turbo. Now, the case for this is because it used less GPU time, okay? And if you want to calculate tokens and these types of things, like I said, I was seeing some discrepancy between the LangSmith values, but the more important ones are actually where you get your token IDs from. So it's Anthropic, OpenAI, and they'll tell you how much you're spending, but it's hard to tell on that specific framework what projects are tied to what's costing money. So RAPTOR, of the 3, this seemed to be the most practical technique. And again, I kind of screened a bunch of these, and I would run. There's a 2.5 hour video that one of the it wasn't Harrison, it was one of the other software devs at LangChain, and he went through a bunch of these and maybe 8 additional notebooks. And when they got to RAPTOR, they said, "Oh, this is its own thing," and then we need to open up the RAPTOR notebook. So then I got the RAPTOR notebook. But in general, it's 10 times faster than the 2 other methods, and GPT-4o giving more relevant response than the 3.5 Turbo. So if you're curious about doing all of this, is I would definitely, don't put in the most awesome LLMs, and especially don't keep running the notebook, because if you haven't got it to work yet, you're going to get charged for it. And even at OpenAI, I have like, say, $22, something like that, just to, get this started. And some of it was credits before, but I still haven't even spent $1 using these GPT-4o, but most of the runs were 3.5 Turbo, and they hardly cost anything, and it's based on input tokens, output tokens, and basically every time you call it, okay? Now, the next steps is basically, I've talked about some of these things, but it's economical to do traces, I believe, and I don't think it traces in LangSmith. It's one of those things, you run the notebook, and then you could still get all these outputs without using LangSmith. But I see the utility of having a separate browser that keeps all of this information. And you can set up your notebooks without even printing all of these, responses. So when it prints it in, Python, they're typically not going to be formatted, right? So anyways, it depends on your taste and what you need out of it. But I'd say out of the 5,000 traces that they give me, like every time there's a specific action being taken, I only used 150 of them, and that was like the whole week. So that was many other notebooks that I didn't even show here. Now, API tokens, here's the other thing, API requests should also be monitored on platform.openai.com and others, right? So, you'll get a feel for it. Like I got a feel for it as far as, when I need to switch over, get my very best results, you're going to have to use the better LLMs, right? There's no way to stay competitive. Now, they did say as far as these types of things is like an agent, in particular, you typically need a higher LLM, and they're more flexible but less reliable. Now, for LangGraph and more of these kind of direct workflows, they're less flexible, more reliable, and so it just depends on a specific research project where everybody says you have to use agents for whatever, and then you would compare it to, say, RAPTOR, these types of things that are more kind of defined and are better results these days. Now, Andrew Ng has spoken much about these, agentic workflows, and so has Harrison Chase and, other people too. And that's in previous discussions. You can see that as well. And that's the sentiment now is the multi-agent collaboration, which I showed you kind of in a previous slide, that needs to get better. And, it's one of those things that, it's still developing. And typically you need to use a higher LLM. And Andrew was the one that actually said, instead of using a high LLM, actually, he said, instead of waiting for GPT-5, which we don't have, use an agent with 4, GPT-4 or 4.0 at this stage, and you can kind of get that performance because it's pointing to a specific data set using some RAG workflow, these types of things. Now, the community is quite strong behind it. So this is actually from GitHub here. And, like I said, the GitHub, actually the Discord is very alive and active as well. So it seems like there's people that either really enjoy helping people or they're part of LangChain to help. So, some are, it's kind of a little bit more lax community, these types of things. But I would definitely, if you have questions, you can go on to theirs as well. And I see with me, especially on the Gen AI portion of this, utilizing LangChain and LangSmith in the future. And then, as far as they say, so Oriol Vinyals said this as generative models are changing the way we think about machine learning and creativity and have the potential to transform industries from media to finance to healthcare. And I think that's what you're seeing in papers now. So, the Drug Discovery Today paper that I've talked about for several weeks, it's one of these papers that puts all of the generative AI, kind of like, the best transformers, the best normalized flow, the best, just whatever's kind of like the leading diffusion. And it also starts to talk about cancer in specific cases too. And I would say in some of the cases when I did ask it about a specific cancer in that, and I would ask it, in table 4 to try to point it further, it's like, it just depends on the method, right? So some of these techniques, like a pure LLM, unless they use some type of RAG, it's going to have a hard time with that because it's compressed and it just learns, efficiently, but it's not like thoroughly or as thorough as we could do it like amongst researchers. So I hope that helped. And are there any questions? So regarding any of the slides, and hopefully some of you have been able to get into this because they say it's the top application in AI that Fortune 500 companies talk about. So, definitely a lot of potential there. And I think that it's already seen, a good number of use cases as well. And I would say most of the ones that we see in literature are not, advanced workflows, so this is The specific example of this agent supervisor is one of the cases. They also presented on two other new notebooks too. And I think I got most of the other two to run. So again, it's easy to change the question, but sometimes you give it a role. So I say to the supervisor, you're an expert in this field of, drug discovery for cancer. And then I have to change it to that as opposed to the previous one. It's talking about some other LangSmith document. So you want to make sure to get that one. And it wasn't as hard as I thought to modify the notebooks based on my API keys, the question, getting it to run, understanding LangSmith. So it does take some to get started, but it's not, it's its own thing. And, you just have to learn just Gen AI software, right? It's not going to change for you. So are there any questions at this point? And as far as the future and everything, where we're going is you're going to see all of these kind of separate pieces come together. So I had mentioned kind of later in the discussion as far as, the central agent and then the code assistant in the upper right-hand corner, and then these RAG LLM workflows in the lower left. And you can still have other machine learning workflows working together in this LangChain environment that say, these small classification models produce awesome outputs, but we need to get that data first, and then it goes into the agent, and then they say, okay, well, based on these results, code this new thing, this new notebook, or, do other updates. And, it's just going to be the topic. So I don't know how many of you know about context windows. So there's other types of technologies for LLMs that are talked about quite commonly. Now, this specific one in this notebook is a Llama 3 8 billion parameters, okay? And then it actually has 1 million context windows, as far as million token context windows. Now, Google just came out with 1 and 2 million, and it's a way of putting all the documents in without having to worry, as it's simpler, right? So you can just put all, that's its context window is like several papers, right? Instead of having to do some of these other workflows. So there's pluses and minuses to doing these types of things. And I think especially in the near to midterm, we'll see the hybrid approach as context windows get bigger, like this 1048K, that you'll not only be, just be doing RAG, or as the context window, goes up, just putting all the documents in there and that it can see all of that. So, it's definitely, there's a lot of enabling technologies, but I would really spend some time with, number one, the LangGraph seminars on YouTube. Those really help out a lot. And like I said, one of the 2.5-hour ones that I did, we went through a ton of notebooks, and just hearing them talk about the important things. And basically, I can sum all of this down to saying, like, you just want a better output. You want a better answer, right? And go through this specific workflow like RAPTOR. It's fast, the high performance, these types of things. So, and it just depends on your specific needs, okay? So we've talked about all this, and I've presented previously on fine-tuning. And, fine-tuning is definitely, it's more laborious. You're basically training an additional small portion of parameters on a specific data set. And, which one will kind of like, definitely you're seeing a lot with RAG. So this, like the, in specific, the RAPTOR. We see a lot with inference RAG, and that's the primary application for RAG right now, is to use it for inferencing, right? So if you go to run a model, I believe, I know Meta.ai uses some versions of RAG, but based on how long it would take to produce an answer, these types of things is like, it's sometimes it wouldn't do it for you because you're not paying it, right? You're not commissioning it to do like a separate RAPTOR, while, you want a better answer for the previous LLM output that you received, right? So it's just important to keep these things in mind. Now, the other one that's been popped up is prompt engineering, and it's probably the simpler of the ones that we've talked about. But there's a paper, it's called Med Prompts, and actually they found that they could just use an LLM and a regular general LLM with better prompts, and it was doing better than other these types of technologies. So if you were to ask yourself, well, why don't you just use them all, the best of all these worlds, do some prompt engineering, fine tune the model, do RAG on it, use an agentic workflow. And it comes down to your application, really, what you're trying to achieve. And again, so I'll open up the chat here and feel free. Okay. Yeah, so so this is for everybody too online. So all the GitHub stuff is on Kevin Kotchak, there's no space on GitHub. And then all the YouTube is under Chemical Q device on YouTube. And there's like over 200 videos there. And yeah, so you can access those through there. And like I said, for this specific one of the 14 references at the end, I put the author's original notebooks, my modifications, and sometimes I do have to add keys and stuff like that. And typically what works the best is using OS. And some of these other ones, they say retry this, and it didn't really seem to work as far as keys went. So I don't have an example on this PowerPoint, but I think you should be really excited about this because the LLMs themselves are costing hundreds of millions of dollars to develop. So that involves training on, terabytes of internet, huge chunks of data on GPU time, human labor costs, and other things. Like they combine supervised learning after the fact just to make it even better. And I think even with Llama 3, like something 15 trillion tokens, something like that, or let's see, 2 times 7, I think it was like in between 12 and 15 trillion tokens it was trained on, which are an approximation for a word, right? So it's a numerical representation. And the previous model, I think, was only 2 or 3 for Llama 2, right? So they're getting more powerful. The context windows are getting bigger. And even if you hop onto OpenAI today, I think they still give you $20, something like that. And you might be limited as far as tokens you can use in a run with like GPT 4.0. But if you put another $5 in, you're pretty close, right? So, and again, I think my current token limit was 10, and then they might have raised it. I don't know. It's hard to keep track of everything. But it's definitely, something to look at. And I'd be interested if you guys have any questions as far as like, I'm coming from machine learning, you look at huggingface.co and you get confused. That's one case. Or you just don't know where to start. And I would start with some of the LangChain demos, on GitHub. That's a good thing too. But I would highly encourage it because other meetup groups I go to, it's just like news. And it's like, you kind of want to be making your own news at this point if you've been in tech, right? So how can I just run a notebook, change it to question, do these bare minimum things, put in the keys, and then start to make other changes, right? That's a good, that's a good impact there. But I think for me, at least, because I've been working on this for many weeks, is that things are transitioning into like, they had talked about production level, for some of these things. And, as far as them ready to go, I think so, right? Because even if the answer is kind of not as explainable, there's still these workflows that you can generate a new answer, right? That's like automated. And it's still not addressing the core issue with the large language model and nonlinear, neural networks, which are hard to explain. They're not like linear like tensor networks are. So yeah, feel free to put in the chat as far as where you're at. And if there's any other kind of like, and again, I'll have these references up in the discussion up later in the day. But, just to get started or to propel yourself, it's definitely, worth doing. Right. So every workflow, there's many of these, right? It's not just, you're just doing agentic workflow. In like a 25-minute video, we went over 3 total, right, for agents. And this specific one is in that upper right-hand corner. So code generation coming from a question, and then, checking. Now, when you look at these two, the diamond is actually an edge, okay? And then the things around the arrows describe the edge, okay? So it just depends on the diagram. Yeah, so as far as where to get started, I would definitely, you have to get up and running on some cloud notebook. I just see way too many advantages, especially at this stage, if you're just getting started. So hopefully you've done some machine learning and these types of things. And, taking that further is definitely, running a model that they put up. And again, put your own keys in, change the answers. Sometimes you have to change the format that you're prompting like a supervisor, like you're telling it, you're an expert in this. And that kind of sets a tone for it. So I would definitely do that. And the series, I might have watched, 3 or 4. So one of these seminars was literally 2.5 hours. And it wasn't from LangChain, but it was a LangChain developer talking about it. And I think I included that link in this specific one. But if you can't follow that, you're going to have to do some code alongs. So code along is basically you find something like transfer learning, which directly applies to this. Like Llama 3 creates these 8 billion parameters, and then I'm using that as a starting point, and I can either retrain the whole thing, I can add some parameters, these types of things. I can use it for something else, but it's essentially that knowledge that Meta, gained, that's set into these parameters in a model is now being transferred to you. And like I said, these cost over hundreds of millions of dollars, to develop. So I would start with something like that. If you want to be more specific, you can come on as well, Shrikant. But basically, are you at that level where you can understand everything with machine learning, with optimizers, learning rates, how to change these, batch size and those types of things as well? Yeah, go ahead.
Thank you. Yeah, I'm good with machine learning and deep learning, but only I need to build up my understanding on LangChain. I also can do generative AI as well, but I don't know where to start from LangChain.
Yeah, I mean, you have to be honest with yourself. So how much time do you have? And then the other thing is like, with LangChain, I would definitely start with a lot of their seminars. Like I said, it has a really good Discord. There's a person that's just always answering people's questions, which is good signs. There's other chat rooms to like post your own work, when you get to that point. And, so how much time do you have? And then, I started off with Hugging Face transformers. And I think Hugging Face and LangChain are just now starting to collaborate. I think LangChain has mostly been OpenAI and Anthropic and these types. But, Hugging Face pipelines is basically it's 1 or 2 cells that you can, import pipelines, import data sets. They have another thing called accelerator if you're using GPUs. And you go to a lot of these models, and then like I did, like, say, for instance, it's called ProTBERT or GPT, ProGPT. And you can, have a pipeline. So you just copy that specific cell, and then it'll already say whatever model it is. It's on the model cards on Hugging Face, okay? So you copy that specific cell, put it into your Colab, run it. And then you change the question, and then another thing with Hugging Face, when you look on, and this is just the feel that I've heard from people, is like, it looks awesome, but you just assume you have to know all of the buttons. You don't, okay? If it's something like a GPT, which is, text generation, you go to, say, GPT 2, like it's proprietary, they don't have the accessible models on Hugging Face. So you go to GPT 2, and then you see in the upper left-hand corner, and you click on text generation. And then when you do that, it'll put everything in the leaderboard as far as it's just right now, it's pretty much Llama 3s and Llama 3 mods. So there's NVIDIA a further fine tuning of Llama 3, 8 billion. I mentioned the million token text or the context window. That's by Gradient AI, and there's Hermes and these types of things. So I would figure out what you want to do, like a specific task. So say you just want to create images, okay? Then there's diffusion, stable diffusion, runway are these are the companies that create the software, okay? And you click on one of them and then click on, it'll say something like text to image or something like that. You click on text to image and all of a sudden it'll pop up all these models, okay? Now on a model card, you can hit the copy, there's like a rectangle, and then wherever you previously used pipelines, you paste it in between those quotes. And as long as it's the same type of model, right? So a multimodal model might work, but for sure that text generation from Gradient AI, versus I think it's news research. NVIDIA has done a fine tuning of Llama 3, 8 billion too. So you have to get something up and running, and I would start there. Like the Hugging Face it has both expert advanced people, but it also has, pipelines. And anytime you see this thing, in my opinion, where it says no code, one line of code, one cell of code, that does very minimal things, right? So by the time you want it to actually do something that you intended it for, it's no longer one line of code, okay? Those types of things, but it's really, do you know what you want to do? Do you want to, generate an answer from text, also with text, or do you kind of have an idea?
Generative, like how to say, models using text.
Yeah, so that's definitely, that's typically you have a user prompt. So you say, just if you went to ChatGPT or if you go to Meta AI, is they say like, tell me when the next biggest, healthcare convention is in San Diego, something like that. And it'll generate a response. But from the sounds of it, if you haven't run these notebooks before, you probably want to start off with like a Hugging Face pipelines. I think that's best.
Okay. Thank you very much. Thank you.
Oh, and by the way, you just like how you're listening to me now, I learned about pipelines from if you type it into YouTube, and a lot of times it'll change your perspective a little bit. And if they don't post the notebooks, I remember they put up a notebook, but then I just wound up figuring out more of it by myself by going to model cards and copying the cells. And as long as they have the necessary, imports or, Hugging Face is transformers, data sets. You also have accelerator, one of those two. And then the LangChain stuff, I would say out of everything I cover compared to that, it's probably a little bit more advanced. But then again, if you know machine learning, and what I would do is, I didn't include it in this one, is just look at the functions and see where it says like define supervisor. And then even if you don't understand all the code under it, you can kind of see how things are chained together and like at the bare minimum defined, right?
Okay.
So yeah, there's a lot of just, you have to learn it, but I would say, whatever specific area you want to, tutorial. So like Llama 3 tutorial, and I've done these before. And, and search for it on YouTube, and then, find somebody that, looks like they know what they're talking about. And if they're working on notebook, code with them. But it just takes time, I would say. Like with any other area of AI, it takes time.
Thank you. Thank you.
Yeah, any other questions? So, and there's no wrong answer. I would rather hear everybody say, haven't started it at all, and then that's our starting point, like, well, did you do any coding before that? And then, now it's kind of going into you coding. So, and there's lots of people, make mistakes. So when you see these notebooks that people run and they're not making errors, look for the little pauses, you know? So a lot of times they'll run code and then you'll see a break in action and then real quick to come back and they say, oh, you know, they had to figure these things out just like everybody else. So don't be discouraged if the first buttons you push just say error. And then just over the course of many months and years, you start to realize, oh, this is just a GPU RAM issue. I just need to change the data set, you know, but don't get discouraged. And yeah, you just want to be building. So just imagine it doesn't work today. And I remember when I really got into machine learning with code over a year ago, you know, I just keep at it. And it took several weeks to actually feel like I was starting to pick up and I would present my results, you know, my MVP, which is like brain tumor image analysis. And over just steady and surely, the more I ran and the more I published my results, if it was just accuracy, whatever, I took that model from like 2 classes to 4 classes to 10 to 44. And I had to figure out all the different, so if this is set to this, then this other thing has to be double that. You know, there's just certain things that they had to be set to. And they're like little treasures, right? And then you're running these all the time. And then all of a sudden, you know, you find yourself an expert, I would say many months down the road at least. But you have to put in the time for sure. And you have to take it seriously. And you could also, Sri or anybody else, you know, say like why you want to learn Gen AI. So beyond just, I want to generate an answer from my prompts, which is, you know, probably the most common way of doing this. You know, is there a specific, like, are there any other reasons, you know, you want to learn AI?
Yeah, for me, basically, I teach machine learning and deep learning. So I wanted to learn that the LangChain and drug discovery as well for teaching
Yeah.
people.
And like I said, a good transition point is talking about transfer learning, and then make sure your students understand that in a traditional sense, like ImageNet. And now say like instead of ImageNet, we have, you know, terabytes of internet data. That's that new data set. And then just like Llama did, and just like, you know, whoever got the parameters off of that convolutional neural network, now it's like we have those parameters, and it's like it's a very consistent theme. Like you're not starting over, right, to get an answer. It's in fact taking a lot of effort and money to get to these places.
Yeah.
But yeah, I would find something like a commonality like that, all right? So people know really well. And say, for instance, in transfer learning, you have this parameter set. I had a colleague, I think only, you know, maybe 10% of those parameters get updated based on your new, smaller data set. And you still have that original context of ImageNet looking at all these images, like man-made and natural things too. And then now you also have you know, that small data set that it's working with to begin with. So that situation is almost identical to fine-tuning a large language model. And these days with a large language model, you could just you could choose to use, it's called LoRA, low rank approximation. So you add on a certain number of additional parameters, which are based on the new data set. Or I've actually done kind of like a pass-through LoRA where I got it to run because just GPU RAM restrictions, and then, you know, just it'll update the actual a small portion of the 8 billion parameters as well. So, and there's the thing with this is you don't want to look at it like it's overly complex. You want to look at it like it's very configurable. Okay. And the more you start to have that perspective, as far as like I mentioned, the prompt engineering, basically using just a stock LLM and doing very good prompt engineering on medical data. And actually, Andrew Ng brought up that paper. It's called MedPrompt. That's one case that you can't neglect, right? And the same thing with agentic workflows today. If it's not a huge thing now, everything's charting it to be, right? And then any other last questions? And I appreciate everybody coming on. So obviously this has been more developer talk, and I think people on YouTube will really like it. And again, all of these are on GitHub, so it's just my first name, last name, Kevin Kawchak, and then especially on YouTube too. So it's simple. It's Chemical Q Device, and then you can get to all the information, through their other sites as well too. Anything else? And
Thank you. Thank you.
yeah, I appreciate everybody coming on, and don't be afraid to make mistakes. And it's just how you first learn machine learning. It's going to be similar types of processes, but say unless you're doing fine tuning, there's going to be some type of retrieval methods that you'll have to learn. So yeah, I appreciate everybody coming on. And this has been Thursday, May 16th, 2024 for the LangChain Suite for Advanced Drug Discovery Gen AI workflows. Have a good rest of the night and have a productive rest of the week, everybody. Take care.
Thank you. Thank you. The slide is available for?
Yeah, so LinkedIn and then GitHub.
Okay.
Yeah.